Hello everyone. The title of my thesis is Prediction of Heating Time of Palm oil based on optimal selection of color parameters. My name is Zerong Zhang. My tutor is Wenbo Zhu. We propose a computer vision model to quickly predict the heating time of palm oil at 180 degrees centigrade. Firstly, we use YOLO to detect palm oil fraction and extract its color parameters. Secondly, we use color parameters to construct the input feature vector and select regression models and classification models to establish the relationship between heating time and color parameters. Finally, YOLO and the best predict model are combined to detect palm oil and predict its heating time. The results show that our method achieves accurate prediction of palm oil's heating time with an accuracy of 97.2%, which can provide a basis for developing an efficient and reliable palm oil quality evaluation and monitoring system. Palm oil is widely used in the frying industry. However, due to the influence of the oxygen, water, high temperatures, and the food components, it produces a range of compounds such as saturated fatty acids. These substances affect the flavor and the nutritional value of the oil and even endanger people's health. At present, researchers mainly study the influence of conventional physical and chemical indicators in palm oil heat treatment, where the prediction of palm oil heating time is rarely studied. When heated at a high temperature continuously, palm oil produces hydroperoxides, hydroxides, and ketones, which cause the darkening of palm oil. Therefore, this study takes palm oil as the experimental object, uses Eurovision to detect palm oil partial, uses RGB, LAB, HSV, gray color spaces, and CIED 2000 as feature vectors of palm oil color during the heat treatment of palm oil, and uses regression models and classification models to predict heating time respectively to provide theoretical and scientific basis for the development of quality control methods for palm oil. The experimental scheme of the model is shown in the figure. The input is an image containing palm oil samples. The palm oil in the image is detected by Eurovision, and the palm oil part is inset according to the detection coordinate information. RGB, HSV, LAB in gray color space, and CIED 2000 are chosen to be used as feature vectors for the palm oil color. And finally, regression and classification-based model are chosen to predict the heating time of palm oil. Data collection follows the following steps. First, we take 500 ml of palm oil in a 1000 ml flask and heat it at 180 degrees centigrade using a thermostatic heating magnetic stirrer. Second, we start timing from the start of heating. We take samples at 6 heating intervals using a 2.5 ml syringe with a long 19G needle and a plastic curette. Third, after the samples had cooled down to room temperature, we collect 5 photos for each sample and use stratified sampling methods to divide them into a training set and a test set in 3:2 ratio. These are the sample images. We use labeled image to train Eurovision. The palm oil images were augmented during YOLO training. The image below shows the original image on the far left. The system randomly applies color gamut changes, aspect distortion, and scaling to the image. On the far right is the effect of a total of 3 augmentations acting together. This is the result of object detection of palm after 58 pulse of training. The average precision of object detection is 100%. We use the well-trained YOLO model to detect and extract color part of palm oil. We choose two methods as the feature vector of palm oil color. One is based on color channel, the other is based on color distance. Color channel-based feature vector is to count the mean value of color channels in different color spaces. Common color spaces include RGB, HSV, LAB, and grade. Color distance-based feature vector is to measure the color difference of palm oil at different heating times as input feature vectors. Common color difference formulations include sRGB, CIE76, CIE94, and CIE2000. CIE2000 is by far the most accurate formula for describing the color difference. These are plots of the variation of each color parameter at different heating times. Where three feature vectors can be constructed by using RGB, HSV, LAB, while only one could constructed by using grade and CIED2000. In the selection of prediction models of heating time, we use common regression models, random forest regression, and SVR, and classification models, random forest classifier, SVC, and BP neural network. This is a setting of model parameters. The kernel function of SVR of those RBF kernel function. The tunable parameters are C and gamma. The tunable parameters of random forest regression are n estimator and max depth, and we use grid search to search the best parameters through threefold cross-validation. SVC and random forest classification are set up in the same way as SVR and random forest regression. This is the best parameter searched out by using research. About the settings for neural networks, the number of input neurons is the number of color parameters, and the number of output neurons is the number of heating time categories. The number of hidden layers is set to 2. The number of neurons in the hidden layer is chosen from 25, 50, 75, and 100. We choose value as activation function of the hidden layer. We choose softmax as the activation function of the output layer. And the number of training epochs is set to 10,000. After several experiments, the number of neurons in the hidden layer was set as shown in the table on the right. Here are the results of the experiment. When we use RGB as the input feature vectors and SVC as the heating time prediction model, the prediction accuracy is the highest, reaching 97.2%. This is a graph of prediction accuracy when using different parameters and different models. The figure above shows the average accuracy when using different color parameters as feature vectors. The figure below shows the average accuracy when using different models as heating time prediction model. We can draw the following conclusions. First, predictions are more accurate rather using 3 input feature vectors than using 1 input feature vector, with RGB, LAB, HSV, CIED2000 grade rank in order of performance. Second, the classification models perform significantly better than the regression models, with SVC, BPNet, random forest classifier, SVR, then avoid regression rank in order of performance. Third, by observing the changes of color parameters at different heating times, the prediction is more accurate when the color parameters with a large range of changes are used. For example, using RGB as color parameters to predict. Finally, heating temperature and the light intensity also influence the prediction of heating time, and these factors need to be further explored and have far-reaching implications for the quality control of palm oil. We use the SVC model with highest accuracy to combine with AUGMENTATION to achieve real-time prediction of heating time of palm oil. Here are final detection results of different heating times. That's my presentation. Thank you for watching.